For Huffman encoding, we want to get an encoding of a given string. And the first thing we're going to do is we record the frequency of each letter in the string. Then we will try to construct a Huffman encoding tree. The Huffman encoding tree can be constructed by repeatedly merging two Trojan nodes with smallest frequency. I will just try to rewrite this frequency table. I'll try to sort it first. So we have B appeared once. We have G appeared once. And we also have M appeared once. Do we have anything appeared twice? We have E appeared twice. Then we have D, I, S appeared 3 times. No characters appeared 4 times, and then we have N appeared 5 times. Then we have A, L, and the space appeared 6 times. I hope I'm not missing anything. When we have this frequency table, we can construct the Huffman search tree by merging 2 nodes with the minimum value. So in this case, we have 3 items, 3 nodes with 1 as a frequency. So we'll merge any of those 2. And now we have a subtree having total frequency of 2. And then we repeatedly do this. Now we have 2, 1, 2, 3, 3, 3, 5, 6, 6, 6 as a frequency. So if we merge the 2 with smallest frequency, I think we may merge these 2. Then this branch or this subtree will have accumulated frequency of 3. And then next step, I think again we will be merging 2 nodes with smallest values. I guess we can merge these 2, giving us 5 as a total frequency. But of course, you can also merge that 3 with the 2. Then the next step, I think again, we have 3, 5, 3, 3, 5, 6, 6, 6. Maybe I'm going to merge these 2, giving us 6. And next step, I think we need to merge 3 with one of the 5s. So let me merge these 2. We get an 8. And the next step, I think we will need to merge 5 with one of the 6. Let me just merge these 2. So the total frequency would be 11. And next round, I think we should probably merge these 2, giving us 12. And then next round, I think we'll need to merge 8 and 6. That's pretty far. Maybe I'll put the space here with this frequency of 6, so I can easily merge with 8, giving us 14 as the total frequency. Then the next step, these 2 are the smallest ones, giving us 23 as the frequency. Then the final step, we're going to have these 2 merged. That will give us the total frequency of 37. So this is one valid Huffman tree. Now to encode each of the character, what we are going to do is, starting from the root node, then we find a path from the root node to each of the character. And every time we pick the left subtree, we put a 0. And every time we put we go into the right subtree, we put a 1. So this is 0, 0, 0, 0, 0. And this is 1. I guess it's needed if I use a different color. Every time we go into the right subtree, we're going to put a 1. Now, for example, for the space, we start from the root node, go left, left, so it's 0, 0. So the space will be encoded as 0, 0. And the character B will be encoded as 0, 1, 0, 0, 0. And character G will be encoded as 01001. And for character N, it will be 0101. And so on. So for each of the letter, we're going to get a unique encoding of that character by some number of zeros and ones. And you will find out that each of the encoding is not a prefix of any other encodings. So this means that if we know if the sender and the receiver shares the same Huffman encoding tree, then they can decode the encoded string and get the original string. So that's the Huffman encoding question we have here. And of course, the Huffman encoding or the Huffman tree for a given input may not be unique. For example, if you put the space here to the right-hand side, or if you just swap any of the two left and right subtrees, you're going to get zeros and ones swapped. But for the encoding result, you will still have the same amount of characters. All right, I think that's everything I need to talk about today. And since it's the last tutorial session, I think that would all be also everything we had in the semester tutorial. I really appreciate everyone joining us over the semester. I hope that I helped at least sharing my idea in solving some of these tutorial problems. If you have any questions, I think we're going to have some consultation sessions next week, well before the exam. But otherwise, I think we've already have the assignment to submit it. So good luck with your exam, and thank you for joining me over the semester. Wish you good luck in the exam, and wish you good luck in your future study and career. Thank you, everyone.
No, she didn't celebrate the party for Yeah. He didn't know who. He didn't know who because Durga put their mother no. Too fucking taken crowded. तुझं वापस आएगा तब हाँ दिल्ली की कोई लिखा लिया Okay.